From design to installation supervision to system warranty, your team at Jensen Engineered Systems is with you all the way.
Good morning, my name is Josh Dragon. I'm with Jensen Precast. We're here at the Cheesecake Factory in Reno, Nevada with the new installation of a Jensen Precast pump station. To my right here we have our pre-assembled valve vault, the control panel for the pump station, and then our wet well with our submersible pumps inside. We're going to go and talk first a little bit about the submersible pumps, and we'll start there and look at some of the components we have in there. All right, here we have our 72-inch diameter precast concrete manhole from Jensen Precast, where we're storing our two 4-horsepower AMX 434 submersible pumps by Homa Pumps. The pumps are on a dual guide rail system. They're currently submerged in the well. For level detection on this pump station, we're utilizing as our primary level detection device a Dwyer Mercoid PBLTX pressure transducer. This pressure transducer is rated to 10 psi, which is 23 feet of head, so it can detect a water column anywhere between 0 to 23 feet. The pressure transducer's diaphragm, now this specific pressure transducer is rated for sewage applications. So what that means is that we got this nice big thick bird cage, and actually the lower half of this pressure transducer is not doing anything for the level detection device. The diaphragm, which you see right in here, is the primary detection device. So the water's pushing against the diaphragm and sending a signal to our control panel. It's detecting a differential pressure between the atmospheric pressure and the pressure it's feeling from the water surface. So that's our primary level detection device. We have two backup floats in the wet well. Those are manufactured by Reno Controls. We'll talk a little bit more about the Reno Controls control panel, but we utilize the floats as basically a backup, redundant feature. So we have a low water float and a high water float. And the low water floats, in both those floats serve in the event that the pressure transducer was to fail, so that the station doesn't go unoperational. But those devices during normal pump cycles are not being utilized. Both pumps are, like I said, on an auto guide rail system. That's basically it for the wet well. We're going to talk a little bit more about the pumps, and as you'll see behind me in a moment, we actually have a cutaway pump, and we'll go into some of the specifics on the pumps. All right, so here is a cutaway version of the same exact pump that's in the wet well. This is, again, an AMX 434 as manufactured by Homa Pumps. Homa Pumps is based out of Connecticut, and Jensen Precast is an original equipment manufacturer that utilizes Homa Pumps in our submersible pump stations, packaged pump stations. Some specifics about the pump we want to talk about today, make you aware of, are, so again, this is a 3-inch, this pump is capable of passing a 3-inch solid, so it's not going to clog with any solid up to the diameter of 3 inches. The inlet of the pump is down here on the bottom of the pump. All sewage is going to enter the inlet right here at the bottom and be discharged out this discharge flange right here. This is made possible by the rotating impeller. This is what's going to be adding energy to the fluid. This impeller is rotating and pushing the fluid against the volute, then forcing the fluid out the discharge flange through our force main pumped 400 feet directly behind me to the city's gravity sewer main. Some things to kind of take note on specific to Homa Pumps is this lower bearing wear ring. This wear ring, not all pump manufacturers utilize this bearing point. What this bearing point does is, let's say you got a real big solid into the pump that knocks that volute pretty hard. It's gonna put deflection forces on the pump shaft and put forces on that seal and potentially cause a seal fail. So what Homa has done to prevent that incident from happening is put a bearing point right here. This bearing point resists those lateral deflections in the shaft and therefore preserves the life of the pump. So again, this volute right here, this is the wet chamber. This is where all our sanitary sewage is being pumped through. As we move up the pump assembly, we then get to the oil chamber. The oil chamber houses a white mineral oil that can be found at any local pharmacy. There's nothing special about white mineral oil in the operation of the pump. What it's doing is telling the control panel if there's been a seal fail in the pump. The way it achieves that is, so in the oil chamber, we have two seals, two mechanical seals. A lower seal and an upper seal right here. If water was to, and then on the top of this, I don't know if you can see it from the video angle, but there's a plug right here. with a hex head in it. If I was to remove the hex head, I could put my white mineral oil in there. And then what I leave in there is a wire with a two-prong wire that's inducing a low voltage current into the oil. The prongs are separated by a minimal distance, and the current is jumping from the prong, and there's a predicted resistance in the white mineral oil between the two prongs. If that first seal between the volute and the oil chamber fails, water mixes with the oil, changes the resistance of the fluid. When that happens, the changed resistance is detected by the control panel, and a seal fail alarm is sounded at the control panel, alarming the operations department that we now have water entered the oil chamber. Now, if water gets in the oil chamber, that does not create a situation where we immediately have to stop using our pump, because water has not entered the motor assembly yet, so the pump's still operational. It does mean, however, that we want to pull the pump as soon as possible, get it to an authorized HOMA motor service shop, and get those seals replaced. Continuing up the pump assembly, we get to the second seal that prevents the oil, and then if it was, the first seal was to fail the mixture, from entering the motor assembly. Inside the motor assembly, we have our rotating shaft. That's voltage is brought in, the current, electrical current is brought in from the control panel. Rotation is induced, and then energy is added at the volute to add energy to the water to discharge it up our force main. So this is again an example of a HOMA submersible pump, and this is the exact pump that we have here at the Cheesecake Factory in Reno, Nevada, that's operating at 120 gallons per minute discharge rate. So that's a little overview. So now we're going to talk a little bit more about the control panel. This is our control panel manufactured by Reno Controls. This is a NEMA 4X outdoor rated fiberglass enclosure. As we enter the control panel, we have a removable key to prevent the public from being able to access the internal components of the control panel. So when we first enter the control panel, a couple things to take note of. First off is our stainless steel dead front door. This is to prevent any operator, maintenance individual from being protected from any damaged internal electrical components behind the dead front door. Off to my left here, you'll notice some of the specific information, specifications related to the control panel as manufactured by Reno Controls. Serial numbers, voltages, amps, those sorts of things. Up here, so this specific control panel is operated by a Siemens Logo Programmable Logic Controller, PLC. That's the computer. The PLC on this particular model has inputs and outputs. So the inputs are such things as the level of the water from the pressure transducer, the high water float, the low water float, things like that. And then the PLC then takes those inputs based on some type of pre-programmed logic, then processes those and generates outputs such as pump run, pump turn off, alarm lights, alarm sounds, things like that. So to figure out which input, so for instance on this control panel, this sticker right here tells us that input 1 is the low level float, and it tells us that the output for output number 1 is to turn pump number 1 on. So that's a little bit what's going on there. As we move to the dead front, you'll notice we got some pump run lights. So these lights are telling us when the pumps are activated. You'll notice also pump 1, pump 2. Everything underneath pump 1 is associated with pump 1. Everything underneath pump 2 is associated with pump 2. To figure out which pump is actually which inside the wet well, you need to refer to the operations and maintenance manual supplied by Jensen Precast. And in that we designate, east, west, north, south to let you know which pump's which, so that you know which ones these correspond to physically in the well. Moving down, we have our HOA switches, which stands for hand-off auto. If I switch the switch to hand, that manually turns on the pump and overrides the PLC, so the computer is not in control. I'm manually running the pumps now. Off, the PLC can't run. And if I switch to auto, this is where we want to leave it typically in normal operation, and that lets the computer run the system and run the pumps. Moving down, we have our overtemp lights. So inside the motor of the submersible pumps is a thermal switch. If the motor was to overheat, the switch would open, break the continuity of that line, and it would tell the PLC that the thermal has overheated, and from there it would sound an alarm telling you that you have a thermal overheat, and that you probably need to check out your pump and possibly service it. Moving down the line, we talked a little bit about, when we were looking at the pump, about the seal fail features of a HOMA pump. This is where the seal fail indicator lights are, so if you see these lights lit up, that's indicating to you that you do have a seal fail. And finally, on any of our alarms, it's going to generate an audible alarm and then a visual alarm. To silence the audible alarm, you can push that button there. There's also another push to silence button on the bottom of the panel that you can depress to silence the alarm. And finally, on the front of the panel, we have our main disconnect. You cannot get behind the dead front until you put the main disconnect in the off position, thereby protecting the operator. So right now we're in the off position, so we can go ahead and enter the panel. So once we're inside the panel, we'll basically follow the flow of energy and talk about the different components that are supplied with a typical Jensen precast pump station. So the inline voltage from the power company is coming in here. This is our main disconnect. It's in the off position. From there, the power travels and is split to two locations. The first location is it's split to pumps 1 and 2, high voltage, and then it's also sent to a transformer up here in the right corner. And the transformer converts a leg of the power to single phase 120 volt power. That's to run the light, our programmable logic controller, and some of the other low voltage components inside the panel. From the breaker, then the power flows to the motor contactors. The motor contactors are essentially the hands of the PLC. This is how the computer turns the pumps on and off. So when the PLC reads an input from the level detection device, in this case is a pressure transducer, to turn the pumps on, it generates the output and it lets the contactor suck in. So you'll actually see that white motor contactor depress in. You can hear the sound as well. From there, the power passes to the overload relays. The overload relays protect the motor from any high current draw. So if there was some type of impediment preventing the pump from rotating and the pumps were pulling high amps, so right now we're set at about 5.5 amps is our thing. So anything above 5.5 amps is going to pop the overload relays and prevent the power from getting down. So in the event that, in the way you would notice that an overload relay was engaged, or excuse me, disengaged, there's a blue dial right here. If that dial switched to manual and popped out, that means that it has disengaged, power can't get through. You have to pull your pump, see what's going on with the pump, you remove the object or what have you, then you would depress this blue switch and switch it back to the auto position, and away you go. From there, the power flows down to the pump cables through the terminal blocks, and the power is then passed to the wet well. Some of the other devices we have in here is the Siemens logo PLC. So PLC is a push button interface. You can move through the menus by moving up and down, left and right. In those menus, you'll see such things as run times, alarm counts, how many times the pumps have turned on, your inputs and your outputs, the date, the time, and then the very first screen will also tell you the actual level of the wet well as produced by the pressure transducer. So that's a good general overview of the components we have inside the control panel. Next, we'll talk a little bit about the valve vault. This is the fully pre-assembled valve vault that was supplied for the Cheesecake Factory by Jensen Precast. In this valve vault, we are utilizing Schedule 80 4-inch PVC. We have a check valve, followed by a isolation ball valve, and then from there the sewage is discharged directly behind me to the city sewer. So again, all valve vaults supplied by Jensen Precast are fully assembled. So they leave our factory fully pre-assembled. So all the contractor has to do is set the valve vault in the hole, make his connections, and away we go. Nothing too special about this valve vault in specific, but one of the things you'll notice when you're taking a look at this is the thrust block that's connected to the right by the 90-degree elbow in this valve vault. The reason we have that is we have some compression couplings in there that are rated up to 200 psi, but they're not rated for thrust. So when the pumps turn on, we want to prevent that 90 from moving, so we have put a thrust block on that. Beyond that, very standard assembly and something that you could expect to see from Jensen Precast. So again, my name is Josh Dragon. I'm with Jensen Precast. Thank you for joining us on our overview of the pump station supplied for the Cheesecake Factory here in Reno, Nevada. Hope you have a great day.